right, this is the third part and the final part in 6.1 for pre-AP chemistry, and this is net ionic equations. Okay, so looking at chemical equations, we have to, there is something called a net ionic equation, which means that some of the compounds are soluble in water, and so the ion, the compound will split up into different ions. And if these ions are present in both the right and the left side of the reaction, then they're going to be canceled out and therefore would not be part of the net equation. Okay, so that's why it's called net ionic equations. And I am going to adjust here because I see it's running off the edge, the word, so I'm just going to adjust here. Okay, so write down, pause the video, please, and write this down, and then I will come back and explain what it is. All right, so for strong electrolytes, and this includes strong acids, strong bases, and soluble salts. So let's look at these one at a time. All right, so we have a list of strong acids, and you need to write this list of strong acids down because strong acids are 100% soluble. Okay, so our strong acids are hydrochloric acid, hydrobromic acid, hydroiodic acid, perchloric acid, which is HClO4, HClO3, nitric acid, HNO3, and sulfuric acid, H2SO4. Okay, so those are all considered strong acids, and when you have these acids in a solution, they will dissociate 100%. That means they'll break apart. All other acids, it's not on this list, all other acids are considered weak acids. Okay, so make sure you have that list. This isn't given to you anywhere, so you need to memorize that. All right, strong bases. Strong bases are anything that ends in OH, remember, is a base, so it's going to be all of your group 1 metals except for francium and hydrogen. So it's going to be Li, look at your group 1, LiOH, NaOH, KOH, RbOH, CSOH, okay, group 1. And then in group 2, it's going to be magnesium hydroxide, calcium hydroxide, and strontium hydroxide. Okay, those are considered to be your strong bases. All other bases are considered to be weak bases. Okay, and then your soluble salts, any salt, any ionic compounds are also called salts, that are soluble in water. And if you'll look at your reference materials, there is a section in those materials, we've gone over this before, that tell you whether those salts are soluble or not. So if you look it up on that list, it'll tell you if it's soluble, and we'll practice this in class some more, as well as the steps for writing net ionic equations. All right, so the first step in writing a net ionic equation is have a balanced equation. So that's why we did balancing of equations first and then net ionic equations now. All right, after you balance the equation, you're going to write the complete ionic equation. So you're going to break apart the strong acids, strong bases, and soluble salts into ions. Then you're going to drop any ions that show up as ions on both sides of the equation. They're going to get crossed out. So whatever you have left is called the net ionic equation. That's kind of like when you have a job and you get paid. Okay, your gross pay is how much you earn, $3 an hour. Let's just say, to make the math easy, $3 an hour. You work 10 hours, that's $30. But they take taxes out of that. So they're going to take taxes out and Social Security out. And if you have insurance or other things like that, they're going to take all of that out. And then what you have left over is called your net pay. Same thing with net ionic equations. We're going to write the equation, the whole thing, separate the ions, cross out the ions that are on both sides, and then whatever you have left is your net ionic equation. Solutions of potassium chromate. So potassium is K. That has a +1 charge. Chromate, looking at our polyatomic ions, chromate is CrO4. It's got a -2 charge. So swap and drop, that's going to be K2CrO4. That's very important that you get these correct, because if you don't, the equation will not balance out. Okay, and it combines with silver nitrate. So silver, Ag, it's got a +1 charge. All right, so remember, silver, aluminum, zinc, and silver in that stair step. Aluminum's 3, zinc is 2, silver is 1. So that's how you remember silver. Nitrate is NO3. It's a -1 charge. So you just smash those together, and that's the formula. All right, so this is a double replacement reaction. So we're going to switch the silver and the potassium. So we're going to get silver chromate. Okay, chromate is a -2, silver is a +1. So we're going to have to swap and drop. And I'm going to need a little bit more room here. So Ag2CrO4 plus, and then we're going to have potassium nitrate. So potassium is a +1, nitrate's a -1, so it's KNO3. All right, now we need to balance this. All right, so we have 2 Ks here, so I need 2 Ks here. 1 CrO4, 1 CrO4. 1 silver here, 2 silvers here, so I need to put a 2 there to give me 2 silvers. That gives me 2 nitrates here, and I have 2 nitrates here. So now that's a balanced equation. We always, no matter what we're doing in chemistry, always have to start off with a balanced equation before we do anything else. All right, so now we need to look at these to see if they are soluble in water. All right, so we just said a moment ago that potassium, any group 1, is always soluble. So we have 2 potassium ions in solution. Okay, we have a chromate ion in solution plus silver nitrate. All right, so let's look at our solubility list. It says always soluble, alkali metal ions plus NH4, NO3. So there you go. NO3 is always soluble. So we're going to have 2 silver ions that have a +1 charge plus 2 nitrate ions. Okay, so that both of those are soluble on the left-hand side. All right, now let's look at the right-hand side. So silver chromate. Let's see. All right, so that's not in the always soluble list. Then in the soluble except, so this is going to be chlorine, bromine, and iodine are soluble except when it's bonded to silver, lead, and mercury. Well, that's not chromate there. So let's see. Oh, look down at the very bottom. Insoluble with exceptions. I see chromate, CrO4. It's insoluble. So CO3, PO4, S, SO3, H2O4, which is dichromate, and CrO4, which is chromate, are insoluble except when it's with an alkali metal, group 1 metal, or NH4. All right, so it's not with those, so this is going to be insoluble. So we're not going to break that apart. Okay, plus, all right, so here we have potassium, which is an alkali metal, and nitrate. Those are both soluble always. So we have 2 Ks plus 2 NO3s, negatives. Okay, so now we've broken that up into ions. So now we can start crossing out things that appear on both sides. Well, I've got 2 K ions here, 2 potassium ions here. There's not a chromate ion on the right-hand side. Silver, there's not silvers on the right-hand side, but we do have 2 NO3 here. So I forgot my negative, and 2 NO3 here. All right, so potassium and nitrate are your spectator ions. So now I'm just going to rewrite this with what I have left. So CrO4 minus 2 plus 2Ag yields Ag2CrO4. That's my net ionic equation. Okay, and our next example, solid copper 2 acetate is dropped in water. All right, so copper 2, so we have Cu, that's got a plus 2 charge, that's what copper 2 means. Acetate, C2H3O2, that's your acetate ion, it's got a negative 1 charge. So swap and drop, that means that we're going to need 2 acetate ions to bond with that. So I'm going to have to put this in parentheses and have my 2 here. Is dropped in water. So I'm going to do HOH. Remember, I told you from here on out, we're going to write water as HOH. It just makes things a lot easier. Okay, so this is going to be a double replacement reaction again. We're going to swap the 2 metals. So we're going to get copper 2 hydroxide. Hydroxide has a negative 1 charge. Remember, this copper is copper 2, so it's plus 2. Hydroxide's a negative, so I'm going to need 2 of those hydroxides. So that's why I put that in parentheses. Okay. Plus H, C2H3O2. So that's acetic acid. Hydrogen's a plus 1, acetic acid is a negative 1. They cancel out, so you just smash them together. Okay, so now we need to break these apart if they are ions. So copper, acetate. All right, so up at the top it says always soluble. The acetate ion is part of that, so acetate ions are always soluble. So I'm going to have copper. Oh, I need to balance the equation. Sorry. All right, 1 copper on the left, 1 copper on the right. 2 acetates here, so I need 2 acetates here, so I need to put a 2 here. Okay, 1 hydrogen here, 2 hydrogens there, so I need to put a 2 here to make 2 hydrogens, 2 hydroxides here, 2 hydroxides here. All right, so there's my balanced equation. Can't do anything without a balanced equation first. So please don't forget that like I almost did. All right. So copper 2 ion plus 2 acetate ions plus, okay, HOH. All right, so this is water. So if we look at insoluble with exceptions, hydroxides are insoluble except when they're bonded with an alkali metal. So hydrogen is considered an alkali metal. So we have 2 hydrogen ions plus 2 hydroxide ions. Okay, and this is going to yield copper hydroxide. All right, so again, hydroxides are insoluble except with alkali metals. Copper is not an alkali metal. Plus NH4, Ca, Sr, and Ba. So those aren't any of those. So copper hydroxide is insoluble. So I'm going to leave it together. Plus, here we have the acetate ion, which is always soluble. So I have 2 hydrogen ions plus 2 acetate ions. Like that. Okay? All right. Cross out what you can cross out. So we have a copper ion here, but no copper ions on the right. We have 2 acetate ions here and 2 acetate ions here. So these can be crossed out. 2 hydrogen ions here, 2 hydrogen ions here. 2 hydroxides on the left, but no hydroxides on the right that are by themselves. So our net ionic equation is everything that's left over. So let's look at that. What I have not crossed out, copper here, plus 2 hydroxide ions yields copper hydroxide, just like that. So that is my net ionic equation. All right, and that's it for net ionic equations. It's the same thing over and over. I worked out 3 examples for you. You have some on the back of your homework sheet that you need to work out yourself. Like always, please slap that like button right across the face. Hit that bell notification and hit subscribe so you know when I put videos on YouTube that haven't made it to Canvas yet.